Some of the most common examples of exponential growth are money and sales and ones like this, where it has to do with a population of something. In this case, a population of penguins, perhaps at a zoo or a wildlife refuge. And instead of it growing by doubling or tripling, we've got it growing by 1%. And that's a lot more common when we're dealing with populations. But it's still going to grow exponentially. You're still going to start with an amount, and instead of it being a straight line, it's going to increase by an exponential growth curve. Let's take a look at how to use our formula in a situation like this. Y equals b times g to the x. Let's begin with what we know, the easy parts. The beginning amount is 325 penguins. We're going to have y equals, and we're going to have an x. And x in this case is going to be years because it's growing each year. All right, let's find our growth factor. And for this, it's not doubling or tripling, it's an 18%. So think of it like this. You're going to have all 100% of your penguins. And you're going to add 18% more each year. So instead of having just all 100% of your penguins, you have 118% of your penguins. All 100 that you already had, plus 18 extra percent. Now let's change that to a decimal. There was the decimal point. Move it 2 spots. So that's a 1.18. That's your growth factor. And if you want to figure out or estimate how many penguins you'll have in 5 years, put in a 5 for the x, and that'll give you a good estimate.